Hello, everyone. My name is Vanessa Escobar, and I work for NOAA NESDIS in the Office of Systems Architecture and Advanced Planning, also known as OSAP. My presentation today will describe the user engagement effort for NOAA missions and how the user needs we assess for instrument development are translated into user requirements that can be traced to areas of economic benefit. We will look at the current plans for GEO-XO and discuss how we're developing value chains for the next generation of geostationary satellites. And more importantly, how we're helping tell the story of how this multi-billion-dollar investment will benefit society. I want to recognize my co-authors, Andy Heininger, Daniel Lindsay, Jeffrey Atkins, and Pamela Sullivan. My presentation today will walk us through the user engagement framework at NESDIS. We will briefly discuss the assessment process of the user community, how we translate user needs into user requirements, discuss the mapping process of user needs to areas of societal benefit, and we will end with some examples of how GeoXO has developed its value chains for recently selected instruments. Before we begin, I think it's important to set the stage for user engagement. User engagement at NESDIS is focused on societal outcomes. We look at how data and products are influencing decisions in the areas of energy, agriculture, aviation, and tourism, to name a few. Being able to trace to areas of societal benefit requires an understanding of the products and services from geo, LEO, and space weather. It also requires knowledge on data gaps and areas that need improvement. This information not only uncovers details for how to best inform product families, but it also traces back to how we can improve future instrument designs and selections for future missions. The job of user engagement is to identify, assess, and share user knowledge inside of NOAA so that the needs of society can inform the user requirements of missions. This is critical because the user requirements we identify feed the environmental problem areas of society that we're trying to address. The user engagement framework is a combined approach of VOI, value of information, and the methodology known as outcome-driven innovation through jobs to be done. These two frameworks are used together throughout the life cycle of a satellite. The process takes in user feedback at every opportunity to develop decisions. These are known as milestones or key decision points. And this is done so the satellite instrument, products, and services are informed with the most current needs of society. The VOI framework looks at value through the actual use of information in decision-making opportunities. The value of information is zero until it is used to support decisions linked to a societal outcome. The value of the information is measured in terms of its use in decision-making. It looks at resources, dollars, and the lives impacted. Jobs to be done is a theory based on the notion that people purchase products and services to achieve a task or a job. This serves as a lens through which customers' needs can be well-defined and communicated. People buy products and services to get a job done, and as we better understand our users' jobs and the data which supports those jobs, we gain better perspective on how to best continue serving the community. Our user engagement looks at the combined value of information and jobs to be done approach to identify data, knowledge, products, instruments, services, and actions that have impact in the jobs of our users. This is why it is so important to not only understand the decision-making context, but why the user need and feedback we collect focuses on the decision-making elements in different thematic communities. User engagement collects a lot of data. The information we collect is solution agnostic, and it spans various categories. Information ranges from user demographic, user type, to the specific needs on spatial, temporal resolution, data format, and delivery preferences. We take this information and assess it at the thematic level. And then we map the needs to different types of NOAA technologies and missions for specific geophysical solutions. The user engagement executed by GeoXO leveraged various communities and built on legacy knowledge of user needs in wildfire, agriculture, weather forecasting, human health, and ocean life at a global scale. We collected information across federal, academic, commercial, non-government, and international communities. The user needs collected not only fed GeoXO, but were also used to help inform LEO and space weather missions, as well as the products and services teams at NESDIS. This ensured that we made the most of our users' time and contributions. To move from a user need into a user requirement takes translation. The translation process takes user needs and converts them into user requirements that help support the mission's decisions and actions in different mission development milestones. The translation also includes experiences from research satellites from NASA, such as TEMPO, PACE, and GLIMMER, bringing together valuable experience and knowledge. A GEO-XO working group, known as the ZORWIG, was responsible for the translation of user needs into user requirements. Here, instrument scientists, product scientists, and user scientists work together to review user needs and convert them into geophysical requirements that could be supported by a geostationary satellite. An example of the translation from needs to requirements for GeoXO can be seen on the top table. Here you see users' needs in wildfire detection requesting data more quickly and at a better spatial resolution. The GeoXO working group looked at the current capabilities of ABI and recommended a 3.9 micron band at a 1 kilometer resolution to better support the wildfire community needs. GeoXO translated over 800 geostationary specific user needs to help support the selection of GeoXO instruments. The actions taken by GeoXO will support and improve observations for weather forecasting, wildfire detection, air quality measurements, ocean tracking, and agriculture through the continuity of weather services, the enhancement of weather services, and the enhancement for oceans, coasts, and climate science. Here you see the current plan for the GeoXO constellation decided in spring of 2021. The constellation calls for a series of 3 satellites. GeoEast and GeoWest will carry a visible infrared imager, lightning mappers, and the ocean color instruments. GeoCentral will carry hyperspectral infrared sounders and atmospheric composition instruments. GeoXO will contribute to weather forecast models and short-term weather forecasts and severe model warnings. This is important for your aviation weather and the decisions made for flight delays and flight cancellations. Multiple instruments included in the GeoXO plan will improve forecasts of thunderstorms that are a common cause of weather-related airline delays. This information will help reduce the forecast uncertainty, allowing airlines to return to operations sooner than later, which directly translates to dollars for the airline industry. A GeoXO infrared sounder will provide real-time information about the vertical distribution of atmospheric temperatures and water vapor to feed advanced numerical weather prediction models and improve short-term severe weather forecasting. GeoXO will also have an ocean color instrument for detecting harmful algal blooms, as well as tracking ocean life, such as whale and tuna. And finally, an atmospheric composition instrument responding to the needs of the health community for improving detection of PM 2.5 in air quality readings. The NESDIS user engagement effort is using GeoXO as a model for future user engagement practices. The lessons learned from GeoXO's user engagement process will build the NESDIS-wide approach to user engagement across all missions. Mapping the needs to areas of societal benefit is done through an expert community of early adopters known as the NOAA Pathfinders. The NOAA Pathfinders represent skilled users that can provide detailed feedback to the mission regarding the uses and applications of data. Pathfinders work directly with the GeoXO mission scientists to help provide an understanding of how GeoXO improvements to the current GOES-R series will improve systems and decisions in society. In exchange, GeoXO will provide perspective into the mission and the product development, as well as share data prior to public release for optimal readiness. The Pathfinders also provide a unique bridge with NASA early adopters to ensure the continuity of observation and skills across to NOAA missions. GeoXO is actively working with Pathfinders, developing use cases for economic studies in flight delays, tuna migration, wildfire mapping and detection, and urban air quality. As we work with our Pathfinders, we develop value chains for each study. We're currently developing 5 different value chains for GeoXO. Value chains provide a framework for organizing information that shows how benefits are generated. In each case, the value chain continues to include specific decisions that are being made and the specific outcomes that are being improved. As we move down the chain and assess all the players involved in the process, we translate information from the GeoXO instrument to the science team to the product development. Then we move into our Pathfinder. As you can see here, our Pathfinder is Wi-Fi for our example, and we begin to translate how the future improvements of geo information generated will impact the products generated by Wi-Fi. We then continue to trace the areas of value and benefit through Wi-Fi's distribution of data to the Ventura County Fire Department. These benefits are then translated to the time saved in detecting fire using artificial intelligence and the cost and the impacts for managing resources to put out the fire, or lives saved due to better evacuation warnings. There are also several unanticipated benefits in this scenario that we need to be aware of when calculating values. Multiple instruments included in the current GeoXO plans will improve forecasts of the thunderstorms that are a common cause of weather-related airline delays. Weather-related airline delays currently result in almost $20 billion of losses each year, and these losses have been increasing over the past decade. By reducing uncertainty of future forecasts, air transportation can continue operating a little longer before storms and resume operations a little sooner after storms. In some cases, this can even help eliminate false alarms. This improvement can greatly impact the $20 billion loss and yield a large benefit to travelers and airlines. As we continue to work with this value chain, we work with our Pathfinders to understand how the future data of GeoXO will help reduce loss and increase benefit to travelers. Over the next few months, GeoXO will illustrate 5 examples of societal benefit in wildfire detection, poor urban air quality, lightning hazards, weather forecasting, agriculture productivity, and tuna migration. This socioeconomic assessment will be completed March of 2022. As we continue to charge ahead, we will officially roll out the NOAA Pathfinder program to the public. We will promote our call for GeoXO Pathfinders through GeoXO tabletops and workshops over the next year and seek to find more use cases for future economic assessments. And finally, please keep an eye out for a joint socioeconomic solicitation between NOAA, NASA, and USGS, where we continue to assess the value of satellite remote sensing data in user environments. Thank you very much for your attention and thank you for listening. If you have any questions about the NOAA Pathfinder program or GeoXO user engagement, please do not hesitate to contact me. My contact information is on this slide, and please enjoy the rest of the conference. Thank you so much.